Hello civil engineers, this is Zubair. Welcome back to new video. In this video, we will see the design of cantilever thread slab staircase. Okay, so here is the given data. The width of the flight is 1.2 meter. This is the width 1.2 meter, and thread is 300 mm, and riser is 150 mm, and M20 grade of concrete and Fe 415. This is the given data, and this is the cross section of that cantilever thread slab. Okay, so here we'll see the solution. First of all, we need to find the effective length. The effective length is 1.2 meter. Okay, 1.2 meter. The thread is 300 mm, riser is 150 mm. Okay, so here, to have marginal overlap between adjacent thread slab, let us assume the actual width of the thread. We have a marginal overlap, that's why we are assuming the actual width of thread slab 300 plus 10. We are considering this 10. Okay, so 310 mm the thread width of the thread. Okay, 310 mm. So now the thickness at support, this is thickness at support, is to be assumed T is equals to L by 10. L is 1200 mm by 10 will get 120 mm. Okay, so at support we have 120 mm thickness, and adopt 80 mm at free end. Adopt 80 mm at free end and 120 mm at support. The average thickness will be 100 mm. Okay, 120 plus 80 by 2 will get 100 mm. This is the average thickness of the thread. Okay, so now we need to find the dead load. So self weight of thread slab, this is the thickness 0.1 into width into density, will get 0.775 kilonewton per meter. And the finishes we have considered 0.6 into the width, will get 0.186 kilonewton per meter. The total dead load is 0.961 and factor dead load is 1.44 kilonewton per meter. Okay, now here imposed load about the live load as per 875 part 2, IS 875 part 2, we need to consider the 5 kilonewton per meter square throughout the staircase and 1.2 kilonewton for free end. Okay, for free end of cantilever. As per the IS 875, we need to consider here 1.3 kilonewton. 1.3 kilonewton per meter square, per 1.3 kilonewton, that is it is act like a point load. Okay, so here case 1, we have two types of case. Factored imposed load in case 1, 1.5 into 5 into 0.3. Okay, this is 5 kilonewton per meter square, will get 2.25 kilonewton per meter. In the case 2, that is 1.3 that we have considered as a point load according to the IS 875 part 2. Okay, at the free end of cantilever. So 1.5 into 1.3 will get 1.95 kilonewton. Okay, so now bending moment, we need to find the bending moment. Due to dead load, WL square by 2, this is dead load, L by 2 will get 1.04 kilonewton meter. Due to imposed load 2.25, this load into L square divided by 2 will get 1.62. In case 2, we have two types of case in imposed load. In case 2, 1.95 into length, 1.95, this is the point load, into length will get 2.34 kilonewton meter. Okay, in imposed load we will consider this one because this is the governing load. Okay, moment. So the total moment will get 3.38 kilonewton meter. Okay, now we need to find the depth, required depth. Will get under root of mu by 0.138 FCK into B. Put the value 3.38 into 10 raised to the power 6 by 0.138 into 310 and 20. Okay, this is the width of the thread. Okay, will get 63 mm. This is less than 120 mm. This is less than 120 mm. Hence, adopted depth is sufficient. Okay, now we need to find the reinforcement. So we have assumed the clear cover 20 mm as per the as 456 for exposure condition. Okay, So we need to find the effective depth. D is equals to overall depth minus the clear cover minus the half of die of bar, 95 mm. Okay. So here we have a formula for reinforcement. AST, area of steel, 0.5 FCK by FY. Okay. Put the values, all the B into D, everything. So we'll get AST 107 mm square. 107 mm square. Okay. Provide 8 mm die of bar. 3 of 8 mm die of bar. Okay. So AST provided, we have provided 3 of 8 mm die of bar. AST provided 3 into 50. This 50 is area of 8 mm bar. Will get 150 mm square. Okay. This is the greater than required area. It is okay. Now percentage of steel will get B into D. B by AST provided divided by B into D into 100. We'll get 5%. Now we need to find a distribution steel, 0.12 BD. So we'll get 144 mm square per mm. Okay. Now spacing, we need to find the 8 mm die of bar. Okay. Where spacing of 8 mm die of bar. This is 50.2 into 1000 divided by 144. This is the area of die of bar. We'll get 348 mm. Okay. So we'll provide 8 mm die of bar at 300 mm center to center. We are not going that much of spacing. The maximum spacing we are providing 300 mm. Okay. Not more than this. Okay. So here now check for anchorage length, check for development length required. So according to the AS456 clause number 26.21, the LD formula we have put the all values 0.87 FY 415 into die of bar B into, this is the what stress bond. Okay, according to the AS456 stress bond for M20 grade of concrete 1.2, we need to add 60% for what high steel deform bar. Okay, this is for plain bar. This is for plain bar. We need to add 60% for high yield steel deform bar. Okay, so we'll get 380 mm. Okay. Now check for shear force at support. For shear force at support, this is 1.44 plus 2.25 into 1.2, will get 4.428 kilonewton. Okay, 4.428 kilonewton. Tau V is equals to VU by BD, will get 0.15 Newton per mm square. Okay. Now this is tau, we'll get this for tau C value less than the tau V. Okay, less than the tau V. So no need to require shear reinforcement according to the clause number 40.1.2.1. Okay, so it is safe in shear. Okay, this is all about the design of cantilever thread slab. Okay, and this is the what detailing. Okay, this is the detailing. At the support we have 120 mm depth, at free end we have 80 mm depth. Okay, so you can continue this depth, but for economical purpose we are reducing the depth at the free end. Okay, no need that much of depth at the free end. Okay, so here 3 of 8 mm die of bar, that is those are main bar, and these are 8 mm die of bar at 300 mm center to center for distribution steel. Okay, so in case of earthquake, this is the LD. This is the LD 380 mm. Okay, in case of earthquake, if earthquake event happens, the reversible stresses will occur. For that, for resist those stresses, we need to provide bottom steel. Okay, we need to provide extra bottom steel, that we are providing 3 of 8 mm die of bar. Okay, this is all about the design of cantilever thread slab staircase. Okay, thank you very much for watching.